All right, if everybody could find a seat or find a comfortable spot. If you need to freshen up your coffee or drink, please do that now. Then we'll try and get started. First of all, thanks for taking time out of your day to come here for this event. This is kind of round one of a power quality energy management push that we're putting on. And what we wanted to do was make sure that people first had awareness to what does that subject matter really mean, okay? And I don't think we can talk about energy management without talking about power quality also, because I think they go together. Power quality means whether or not your equipment's running, right? So downtime is pretty paramount for anybody that's producing anything. And energy management, we really need to understand what that means. For me, it's trying to look at energy as a raw material, because it's part of the cost of your process, and it's part of what you should think about as far as dollars per widget that you produce, whatever that widget might be, okay? So what we did is we partnered with a company called Energy Insights to give us a real good look at utility rebates and legislation that can help pay for part of your capital expenditures or help you pay for studies to look at energy improvements. Because whether or not you know it, you're paying into the program, so it's your money. Would you like some back? If you would, you should pay attention to this, okay? So with that, first of all, Matt is the president of Energy Insights, and he has a team of, I believe, 15 folks. So they're going to be putting on a presentation for us. If you have questions, please feel free to raise your hand and ask those questions. After the fact, I'll kind of wrap things up and then invite you to hang around and have some offline conversations with us if you have some specific questions that you want us to address. So with that, I believe, Tanuj, you are the star player today. So there we go. Thank
you. I guess we are good. So today we'll be doing introduction, energy billing, power quality, energy management, and some of the case studies. So we are hoping that we can cover some of the topics that that you guys are looking for. Introduction, here is our team. Matt Haley, as you heard, is the owner of the company. He's the president, and Tyler Burrell is one of our senior project managers. He's out of California office. I'm a senior energy engineer, and I'm in Chanhassen. But we have other folks on the team, chemical engineers, mechanical, and energy analysts. So we have a whole range of different areas that we try to bring in to bring more experience, bring more knowledge, because sometimes engineers, we just like to look at numbers. We need somebody who can translate those numbers for you folks, and you folks can bring it to your superiors or decision makers. But I do want to thank you and Werner for making this happen, because remember, a lot of you folks are told, save energy. This presentation will at least try to help you when you are told to do so, what questions you should be asking. How do you save energy? Where do you start? So this presentation will take you folks from when you're asked this question, hey, save energy, to what you can do to save energy. Energy billing. This is the primary tool. When people say, hey, you have to save energy, what I always recommend, get the last 2 years of bills. Put those bills down. And if you are doing things, let's say a company hired you a year ago and you are already doing projects, ask the people who are asking you to save energy, when do you want me to start? What year you want me to use as a baseline? Should you be counting all those efforts that you have already put in to save energy? Are you seeing the changes in your bills? So having a spreadsheet, having numbers in front of you will help you make the decision. Always pick that one year that you will start saving the energy from, because it's very hard to justify energy savings if you don't have something as a baseline. A lot of people like different formats. Some people like Excel spreadsheets. I have a photographic memory. I like graphs. So whatever works for you, whatever works for you to show those numbers to the decision makers or even for yourselves. I can say myself, hey, I'm saving energy, but if I don't have a proof, it's hard to justify. So what you do is start with your last 2 years of bills. And once you do that, you will be surprised to see a lot of things that go behind the scenes. When utility is telling you that we are charging you 5 cents a kilowatt hour, it might not be 5 cents a kilowatt hour. We have seen places it's almost double. So putting that information in front of you will help you ask questions. If I'm supposed to pay 5 cents a kilowatt hour, how come dollar per kilowatt hour is coming out to be about 10 cents? Once you have that in front of you, then the question comes, should I be saving energy or should I be saving cost per kilowatt hour? Let me tell you, my friends, you cannot control cost per kilowatt hour because somebody up in the utility is making that decision how much the rate should be. So what you can do, you can only save energy at your end. And then take some steps to bring that cost down. But again, that is out of our controls because rates are going up. So for you to say, hey, I saved 10% in the cost from last year, it might completely disappear by the end of the year if the rates go up because you are not seeing those cost savings. But you can control these costs, and we will discuss those ideas, what you can do to make it happen. So what I usually do, I take 12 months of data, I put it in a spreadsheet. You can see that it comes out to be 360, 365 days. Next is measured demand. You talked about you are here to learn how to control power factor. Before you even control power factor, you got to figure out how are they charging us, how are they dinging us for that power factor. A lot of times they won't tell you that you are being charged this much amount for a power factor correction or because you're lower than expected. What you will see on your bills, you will see a column that will say measured demand, and then there will be another column that says bill demand. And at times, bill demand might be different than measured demand. Then you ask the question, why is that? And that's where you figure out you are being charged for power factor. Other things that we like to look at is, as I said, you plug in your kilowatt hours number, you plug in your total cost, you come up with dollar per kilowatt hour, and all of a sudden your 5 cents per kilowatt hour rate book, that it says in your rate book used to be 5 cents per kilowatt hour, now you're all of a sudden you're up at 10 cents a kilowatt hour. Why? So you ask that question. Any time any utility is trying to do a rate change, what they do is as soon as they file the paperwork to the government, they try to forward those charges to you guys. And how they do it, when you look at your bill, I wish there were only 2 line items, demand charge, energy charge, but there are a ton of other, resource management. You ask them how is this calculated because every month you see is different than the previous one. What is that? All those hidden charges, all those riders. So until and unless you see that bill and you are given the task of controlling energy, you won't be able to do it until you have that bill in front of you because you are the one who should be asking these questions that we'll be discussing today. Power factor we just talked about. Load factor. If there was a warehouse that was running 24/7 and all it had in the warehouse were lights that were on all the time, I would see this number close to 90-95%. When this number is down below like this, what can you do in your plant if you have 2 shifts to balance those processes? Is there something that you can you run the process in the morning and run the packaging in the evening, or something can be done so this number can come up? That's again totally up to you guys how you run your process. But if this number was in 60, 65, 70%, it would be a good number to be at. Load factor, power factor, and we will discuss how we calculate these. Here's a graphical format of what values we just saw. You can see in month of June, July, August, and September, my energy is going up. And you all can guess what's happening here. It's summer, right? But if somebody comes in and tells me, hey, I can save you a lot of energy on your air conditioning, okay, if I don't have this in front of me, how would I know that they are lying to me or they are telling me the true story? Because look at this, little over 500, little less than 700. So about 150 kW I'm spending on my air conditioning load for summer, and if somebody's telling me they can save a lot of money, you should be asking the questions, how much is a lot of money? If you have these graphical formats in front of you, if you know exactly what's going on with your plant, you should be able to ask the question. Here is, for the same place, look at the kilowatt hour. This is the kilowatt hour charge. Yes, I can see some kilowatt hours going in August and September, my usage went up. But again, you can ask the question, did I run extra shifts? What product I was running? Was my cooling running a lot? So things like those can be generated from these. Same thing on the gas side of things. Okay? When I look at this chart, this is a food processor. When I look at this, what I see is that winter months is not affecting their usage much. They are running a flat load. And I will, once we go down the slides, I will show you, this was the customer where somebody walked in and told them, hey, we can save you half of your gas usage if you switch your heating equipment in the plant. So, and that customer was about to bite on that. They were going to change their heating equipment to infrared heaters all over the place so they can save half the energy. Now, if they would have this in front of them, if they would have done this exercise, that wouldn't have even been a question, because then the owner of the company would have told the person who was selling heating equipment in there, do you even know how much gas I use? Do you even know how I use my gas in the plant? Again, the point being, if you guys are given the tasks to save energy, you should be doing some of these things to help yours. This is a chart. These are the graphs that we do. At times, it's hard to justify the savings just on the looking at the graph that I initially showed you. You take the energy usage and figure it out. This customer was telling us that in the plant, inside the plant, the weather was playing an important role in their energy usage. So what we did, this is weather normalized, production normalized data. And we found out after this exercise, no, weather wasn't affecting, the production was affecting. Again, a good thing to do, good thing to weather normalize, good thing to production normalize your kilowatt hours. Try to come up with what is that BTU per pound or BTU per unit you guys are producing, what is that energy? If you do that and you save energy, then you can go back and prove to your superiors, hey, even though you're not seeing it in my bills, but look at this, we are producing more parts. I'm using less energy per part produced, per pound produced. Again, simple exercises you guys can do in-house. If you can't, ask Werner for help. They can help you out, make these happen, set these up for you. So what we learned from this? Come up with a facility baseline. Come up with a baseline that you will base your future energy savings from. Facility peaks and swings. Once you do this exercise, you will see those peaks and swings. Load factor. We talked about load factor. What you do, you take your total kilowatt hours, you divide that by demand, the maximum demand, and you divide that by hours that you are running. That will give you the load factor, how loaded you're running in your plant. Actual dollar per unit term, dollar per kilowatt hour. We just discussed this fact. Once you do this exercise, and this one is a good one to have. A lot of times what we have seen is, let's say you are proposing a project to your superiors. Hey, I want to do this project. And what you do, what a lot of people do, they just take the base rate that's in the utility rate book to propose that project. And if that rate that you're actually paying is twice the amount of what you should or what is in the rate book, guess what? Your payback will be cut in half when you're using the actual dollar per kilowatt hour or dollar per therm you're paying. So again, doing those exercises, putting those spreadsheets together will help you decide what number to use in your calculations. Normalize, we talked about weather, production normalization. Leads into rates and tariff inquiries. Once you see those rates, then you can go back and ask the Excel rep or Minister of Power rep, whoever rep is that, hey, why am I paying this higher rate? Think where the energy is going. what can you do to control this? Again, if you're given the task to save energy, look at those bills. Ask the corporate office, give us the bills. We want to look at these bills because it will help us do our calculations. Look for meter charges. There was a plant we did last week. Werner has. I'm looking for Randy. Yeah. Last week we had a customer who came and told, asked Randy, what can we do? They have a lot of different buildings, and each building has a meter that has a charge on it, a meter charge. Plus, each meter has a peak that's killing him. It's 30 meters, and there are 30 peaks that they are paying separate for. Can they join the meters together? Can they have one meter as the electricity come in the plant, and then from there, I personally think that they will be saving on demand charges, because now rather than having all these different peaks on one meter, they will have just one peak on one big meter. Now, there is a reason for this craziness. Whoever did this in the past had separate meters, wanted to see how much each building is using. And that is important too. But there are ways around it. You can do with real-time monitoring now. There are meters available that you can install on your each building, on your processes, that can help you make those decisions what that building or what that meter is using. And now when I say real-time, that means rather than waiting a month and a half later what you did in your processes, now you can see right now what's happening in your plant and make those decisions. So, actual demand versus bill demand. We talk about that. If there is power factor, what's causing the power factor? Outage reports. There was a food processor in Iowa that we worked with. They had this huge peak, and that occurred because utility had outage. Okay, why there was this peak? Because it was a huge plant. They had to start the whole plant. Refrigeration ran because they had to bring the coolers, freezers back to the temperature they needed them. And then after that, after they hit that peak, they were billed a ratchet. A ratchet is when your plant is hitting a peak, utility has to produce that much power or have that power available because they know your plant can use that maximum power. How we found out that they were hitting a ratchet? Because for the next 12 months, we saw exactly same amount of demand on their bill. Not the actual demand, not the meter demand, but the bill demand. So we asked the question, hey, in this month, how come all of a sudden you are using 150 kW or 500 kW more than what you were using on an average? After doing some digging, talking to the plant managers, talking to people on the floor, oh, we had a huge outage. Somebody took the line out or something happened. So we went back to the utility and told them the reason. First thing they did, they took him off the ratchet. Second thing they did, they gave them a report. They asked them, every time you have an outage, we want you to track it on a piece of paper and fax that to us so we know that this is happening because of us. So they got a huge refund back because now they were not supposed to get that, but it happened to them. Riders we talked about, what's going on behind the scenes. Dollar per kW, at times we have seen double the charges on the rate book. Sales and use tax, we will get into that in a minute here, but that's again a very good point to discuss. Highly recommend you folks to sit down with your utility rep and tell them to do an annual rate review. What happens? Let's say your production was 500 kW, right? At that point, whatever utility thought would be the best rate for you, they put you on that, right? Now your production has gone up, you're still on that rate. If you don't ask them every year, at least once a year, hey, why don't you run my rate review, am I on the right rate? All these reps in their computers have spreadsheets built that they can plug in your last year's usage, and I can tell you this will be the best rate for you, or give you options. So think about doing that. 15-minute interval data. For a lot of large customers, you can get 15-minute interval data, but again, the problem is, it's a month and a half. I can't remember what I did yesterday. Periodic meetings with reps, not only for your rates, also for what's available in rebates. Sit down with them. You guys are paying their bills. Have them come in and talk to you. Water and sewer charges, another good example. And it's not a problem anymore, but we have seen it still is out there. If your process uses a lot of water, and you have just a water meter coming in, you pay almost twice the amount for sewer charges because it has to be treated. We have been to plants where it made sense to pay $1,500, $2,000 to put in a separate meter, because now you know how much water is going in the sewage. You don't have to pay the sewer charges because evaporation from your cooling towers, water being used in the process, can help you reduce that water going in the sewage. So if you don't ask for it, it's taken for granted. Water coming in will be going out. Real-time monitoring, we talked about this, we'll be covering that more in details, but Werner has equipment that you guys can take and install on your devices. If you want to know how much my cooling tower is using, how much my refrigeration compressor is using, there are devices like these that you just put around the wire, one of the phases, and it will. In the past, it used to be you have to collect for a month and then you look at the data. But now with this technology, it sends you to your computer how much as it's recording the data. So again, there are things like these, very economic. I mean, you can install these on your motors and try to figure out, or loads, try to figure out what's going on, how much you're using. Pies. Everybody loves pies. Start using them in your business too. Exactly. Yeah, you tell me about it. Okay. So here's the good one. Okay. Somebody comes in and tells you, hey, I can save you half the energy if you upgrade your lighting. Guess what? You are going to your superiors and asking for funding to do lighting, and you're telling him, this guy's telling us we'll save half the energy. It's only 5% of your load. Guess what? If the next month your production is a little higher, 10% higher, that 5%, 50% of 5%, you will never see on your bills. So do this exercise. Use these meters to install on your equipment. Figure out how much energy is going where. And then once you have this pie in front of you, you know how much energy is going where. And then based on that, you can decide, hey, refrigeration is 33% of my load. I better go ask funding for refrigeration. Lighting, let's do just as it fails because I won't see the savings. But again, there are other things behind the scenes, maintenance, or how much money you are spending on maintaining those lights, or has it become a safety issue because the lights are so dim? In that scenario, yes, you have to do that. But again, this will help you decide what and where you should be investing to see the biggest bang for your buck. Here, this chart was based on demand usage. This chart is based on energy usage. Perfect example why you see that refrigeration only is 33% here and 45% here. Depends on the weather. Your refrigeration compressor might be 33% of your refrigeration load, but at times it will be running more hours, more kilowatt hours. So that's why you see the difference. This was example that I was telling you about heating equipment. It was being preached to the owner of the company that change your heating equipment, but heating was only 1% of the total load. The rest was actually the boiler they needed for production. So yes, if they install better controls on the boilers, they will see more savings, but I didn't think that they will see the savings on their heating equipment. Analysis of energy usage by category. That's what these pies help you with. Project management by category. You will know from these pies where you should be spending the energy to see the savings. Funding for improvement by category size. It will help you once you are asked the question, hey, I'm using too much energy, your job is to save energy. Then you say, here's the pie chart for you. This is where I'm using the most energy. How about we concentrate on this, bringing this piece down. Prorate study by department. One of the food processors just hired us, and Werner was helped too in this. They hired us to do these pie charts for every department. There are 26 departments in the plant. Why they want to do it for each department? Because they want to decide how much funding should be going to each department and which category should be going for. So again, very important tool to have. Utility rebates and incentives. We all know there is a ton going on. Periodic meetings with the reps for updates. What you do, you have a project list that you are doing for the year. You have that funding available that you know that you have these projects that you have to do in this fiscal year. Bring it to them. Say, hey, listen, I want you to put it on your project list. I don't want to miss out on any rebates. Guess what? You are paying in the rebate programs. According to a law by state of Minnesota and other adjoining states, everybody pays in the program, and you are supposed to get rebates from those funds collected. Okay? Now you have a great service rep with you, Werner. So guess what? Not only go for money you paid in your program, but for your neighbor's money too. Right? It's a rebate program. Go for it. Familiarize yourself with prescriptive and custom rebates. A lot of times they will try to stick you to prescriptive rebates. Perfect example, you see this fixture right here? It was installed in an ice arena. Okay? We could have done, customer could have got a prescriptive rebate from changing one light to the other light. What do you think all the heat produced from the lights in an arena is doing to the refrigeration compressors? Right? So we went back and told them, listen, you cannot just give these guys prescriptive rebate for changing lights. Look at the bigger picture. Now their compressors are running less. So guess what? The rebate went from prescriptive to custom. And when it goes to custom, you are pulling the maximum rebate that you can for the things you are doing. Ask for other potential. Go ahead.
Greg Clark with Excel Energy was going to be here today, but unfortunately wasn't able to make it. But I went to their seminar 2 weeks ago at the Excel Energy Center. Their big message was they're giving rebates on energy efficiency improvements. You might actually be using more energy if you're making more widgets, but they're very open to the idea of custom rebates, and they're very focused on increasing your energy efficiency of your process or building. So
exactly.
So I would encourage every one of you to go back to Excel. If you have anything that you think is going to save energy, they're very receptive to it.
And the thing with custom rebates is you have to get them involved before you cut a PO. That's why having these quarterly meetings with your reps, and your rep that will be discussing your rate might be different from the rep that will be discussing your rebates. So get the right people involved. Ask them, are there any funds available for recommissioning studies, for other studies, and there are funds for them. If you won't ask him, you probably won't know about them. Maximize your rebates, we just talked about these. Sales and use tax. In state of Minnesota, any gas, electric, and at times water you use for your process, you're not supposed to pay taxes on that to your utility. So if your taxes on your electric bill, let's say it's $5,000-$6,000 a month, and you're not paying 90-95% of that, that makes a huge difference. A very good recommendation if your superiors ask you, hey dude, give me cost savings. Look for this for the first thing. When you pick up your bill and you look at your last line item on the bill right before the total amount due is tax. If it's total 6.5 or 6.75 for Minnesota, if it doesn't say 95% exempt or something like that, then you're not exempt. Then you should start digging into that. You should start asking the question how much energy I'm using towards my process. You don't have to pay taxes on those. Just thinking on those lines, you only pay on non-process, right? What if you do projects in your plant that brings your non-process percentage down? Let's say 10% of your plant is electric lighting. Now you replace that lighting with energy efficient lighting and you bring that down to 5%. Right? Now you're going from 10% to 5%. Not only you're saving energy, you're getting rebates to do that project. Don't stop there. Look at your exemptions. Because guess what? Your exemption is going from 90% to 95% because rest of it is going in the process. So revisit this exemptions every 3 to 4 years. And in state of Minnesota, they allow you to go back 3 years to get the refunds on those sales tax exemptions. And if you need help, please connect with Werner and they can help you out with those. Here's an example. This is how the study looks like. The study is usually 30 pages long, but that's what it says. Process 88%, non-process 12%, so the customer will only paying 12% of the tax they owe to the utility. Here is in a graphical format why they only owe 12%, so this is the example. Here is on the electric side, 14% tax only owed for non-process, rest should be exempt. Power quality. Power factor. What is power factor? A lot of people are not clear about this. I love this example, and I go in a bar. I usually go in a bar. I ask him, can I have a glass of beer? There are two ways of pouring the beer. One, you open the tap and stick the beer glass 2 feet underneath. Guess what happened? I have this much foam, this much beer. I'm paying $4 for the beer. But a good bartender would make sure that I have the least amount of foam. I'm still paying $4. Guess which one I like? More beer because I gotta order less. So when you have power factor, energy can only be changed from one form to another. You have a motor in your plant or any process that's producing a lot of heat, a lot of waste heat. Processes that not only do the work they're supposed to do, motors, but also make extra heat, waste energy. Those are the reasons for power factor. You still will be paying $4 for that glass of beer. You still will be paying charges for making that power factor in your plant. So it's your job to reduce that power factor, reduce that waste heat in your plant, because the utility doesn't care. They will charge you for it. What can you do to reduce that? You can install capacitors that Werner sells on each and every piece of equipment that you know is generating power factor. Or you can install a capacitor bank. As soon as the power comes in, it passes the meter, you have a bank, it's going to make sure that power factor is reduced in your plant. Or you can do energy savings projects that can reduce those power factors. Variable frequency drives, efficient lighting, all of these are really good candidates to reduce your power factor. So the ratio of the real power flowing to the load to the apparent power in the circuit. Foam, good beer, and foam. In an electric power system, a load with a low power factor draws more current than a load with a high power factor for the same amount of useful power. Linear loads with low power factors, such as induction motors, can be corrected with a passive network of capacitors or inductors. The devices for correction of the power factor may be a central substation, like we discussed, they can be central, or spread out on the distribution system if you know which equipment is causing that power factor. A circuit with a low power factor will use higher currents to transfer a given quantity of real power than a circuit with a high power factor. Again, we are talking about the same thing, but in different ways. Whatever clicks, we gotta reduce power factor. Harmonics. This is another one that has picked up a lot in last few years. Result of non-linear electric loads causes power quality problems. Results in increased heating in the equipment and conductors, misfiring in variable frequency drives, and a ton of other problems. So power factor and harmonics are the two things that you have to work on. And a lot of people say, if I reduce power factor, will I save energy? No, you won't. Power factor is a cost reduction technique. Power factor correction is not energy savings. Sales tax exemption studies will not bring you energy savings. Sales tax exemption studies will bring you cost savings. So if somebody comes in and preaches you, install this black box, it's going to save you energy, and it's a power factor correction, it's not happening. Eaton is a product sold by Werner, offers a free power factor site evaluation. Take advantage of it. Energy management. Can control what you can measure. There are technologies out there that you can use. Some of the utilities use this My Meter. When I get my electric bill, they tell me how much my neighbor is using. And I go turn off all those lights. My wife goes behind me, turn all of those on. So having that perception, looking at those things in front of you helps you. That's why I was saying meters like we just showed you, install those. It's going to help you make your decisions. When you see the power being used, it will help you decide. Energent is another example. E-gauge, that equipment that we just send around, that's actually E-gauge. Hoboware is another one. Hoboware just looks like this. You install it around a face and you go back 2 weeks later and see how much power is using. E-gauge, on the other hand, will send you data to your computer showing you how you're doing it. Again, I can't remember what I did yesterday, but if you have something like E-gauge installed in your computer and all of a sudden you see a peak, as a plant manager, as a decision maker, you will go out to that motor or to that circuit. What's connected to this circuit that's causing this peak? That might be the problem in my production, why my peaks are going up. We'll play this video. This customer installed this power solution, again demand control. So it's going to help you with your decisions.
My name is Chris Buck. I'm the plant manager of Donsko Incorporated. We're a gray and ductile iron foundry consisting of 2 foundries and a machine shop. What began as a small foundry making hardware, a couple thousand pounds a day, has turned into a highly automated facility where we're producing up to 150 tons a day of castings for many of the top commercial and industrial manufacturers on a global scale.
I've been extremely happy with PowerIt's energy management system since day one. It was the cleanest installation of anything I've done here at the foundry. Technical support's been great, customer service has been great, and I think the company being proactive is seeing what the foundry's needs are, what we're looking at next, where the industry's going.
Well, obviously, the number one value to the Sparta system is money. And we're earning $13,000 a month off of our utility bills through demand control and the 2 demand response program. The software system has some added benefits as well, both from a maintenance point of view and from even safety and training. Just last night, hopped on the computer this morning, and so we earned $600 worth of savings and no impact to our operations. This is through taking advantage of the synchronous reserves demand response programs that continually occurs as we're running our plant.
Synchronized reserves is a program where, I'm not sure where the country has, but it's implemented by PJM, where we actually, a week ahead of schedule, we tell them 24 hours a day how many kilowatts we can shed at any given hour. And we've had probably, I don't know, 15 events this year. I think year ending's probably to be close to 70,000 just from the synchronized reserves. We've generated quite a bit of revenue from being a part of these demand response programs, and I'm 100% sure that when we have an event, that we'll comply with it. In the savings, if I had the savings on our utility bill, we're probably generating over 6 figures a year just from the demand response plus our savings and electricity bill.
That signal comes in through the Ethernet, completely autonomous, and whenever the SPAR system receives that signal, it goes into a predefined demand response schedule that we've defined. So we can define how many megawatts that we're dropping by every hour of the day.
So we're pretty ahead of the curve, I think, in terms of how we monitor our electricity bills in the foundry business. So as a tool, it allows us to control what our peak demand is for the day. I call it my peace of mind when I go home, that I can look at the furnaces, I can look at the power. No one can lie to me now how much power we have to our furnaces.
One of the things that we were concerned about going into any kind of a demand control or demand response project was, what is it going to do to our plant operations? Because we're in the business to make castings. We're not in the business to sell power back and to get rebate checks for demand response. One of the nice byproducts, we haven't been impacted at all. And as far as our demand response programs, we have not seen any impact to operations either. But I can say right now, this $13,000 has pretty much been free money.
Our goal here is about 5 tons an hour. I've seen over the course of shift over 5 tons an hour and shed 8 times over that course of the day. So we have not seen any reduction in production. I'm very happy with the result.
I can go back and I can start looking at kilowatts, and we can get a good idea from a maintenance perspective on what's going on in the plant and at what time things are going on. But we also use it for training. I can go in and I can look at the kilowatts or the kilowatt hours consumed over a weekend when I don't have operations running in the plant. And I can come and I can see that when my melt department crew comes in to do the furnace maintenance, I can see the kilowatts when they turn an air compressor on. So we use this as a tool where we can see, since everything is time stamped, we can sit down and we know when the buttons were turned off, when the buttons were turned back on. And if an employee would be walking away from the furnace and leave it unattended or leave it run for too long, we can sit down and we can go over this because this is a serious safety issue. So there's been the added benefits both on the maintenance side and the safety and training side. But still the primary goal is it saves us money.
We've been using Spera for about 3 years now. When we implemented it was for shaving peak demand, and we saw probably a 10% savings in our energy bill every month. But what we've used it for recently over the years is, one is to stay ahead of the energy rates coming from PP&L, that we don't know where the market's going to go. So we want to have the ability to control our demand at any given time. Number 2, we've used it for demand response, automating the demand response so we're 100% accurate. And the third thing we've actually used it for is training of our employees, which I've personally found very beneficial. I'm extremely happy with the Spera system, as it's helped us save 10% on our demand and our bills. It's generated a decent amount of income over the last 3 years as a part of synchronized reserves, and it has helped immensely in our training of our employees, all with the benefit of not inhibiting production.
Things that you can do in your plant. First, start with energy audits. Have folks tell people that are doing the audits, I want ASHRAE audits done. Some of these audits will generate those pie charts we have been talking about. Now, if I'm an auditor going in your plant to do these audits, generating those pie charts, these will be very, they won't be the exact numbers because you have been in there forever and I'm going there for half a day. So it will give you a starting point. You can refine it more based on what you know. But again, these audits can help you with those pie charts. These audits can help you make put some numbers to some of the projects that are in your mind that you can discuss with the auditors. Recommissioning, commissioning, and retro-commission, again, a very good one to think about. A lot of plants, a lot of commercial buildings have all these rooftop units, have these air conditioning systems that you think are running collaboratively, but they probably might not be. So having the study done, and again, there are tools that you can probably install in your plant to learn about them before you even get to this point, and we will discuss that as well. Compressed air, refrigeration, boiler, vacuum pumps, motors, lights, controls, HVAC. Again, these are some examples that are very common in a lot of plants. And yes, as you start tackling these categories, you will start seeing savings. Going back again, if you think you are saving electricity, you should be eligible for a rebate. At times, you don't have to replace something new, replace something old to get a rebate. A lot of people think that, hey, I bought this new piece of equipment, I didn't replace anything, so I might not get a rebate. No, run it by your rep. You are buying a new piece of equipment, you could have bought a crappy piece of equipment that would have used more energy. So you can do that analysis and show it to your rep. Why am I spending extra money to get that equipment? There are energy savings, there can be rebates for them. Energy teams, highly recommend doing this. What this is, and we have been very successful as we are working with plants, if you have a Werner rep that's selling you drives, if he is involved selling you electrical equipment, lighting equipment, get yourself on the team, get somebody who makes a decision in your plant on the funding, get them on the team. They shouldn't be, the people that are approving your funding shouldn't be the only one that's only see you once a year because you're trying to get funds out. Have them come to these meetings. Tell them the reason behind your craziness because you have been given the task to save energy and what it takes to save energy. Get your electric, gas reps on the team. Once you meet every quarters, they have this project list going. You guys are tackling projects. Once you leave the room, then everybody has 8 tasks they have to do it before they come back in 3 months and sit down again. And that way you won't miss out on projects, you won't miss out on custom rebates because you're already keeping them ahead of time. The people that are making decisions to give you funding, they know what you are thinking, why this project should be done. Again, have that team, have people involved, and yes, ask for help. Ask for help. If you have never done that, we can help you set these up. Analyze benchmarking reports. This is what energy management should be. Specify internal goals. Familiarize yourself with utility rebates, offerings. Analyze the results of assessments. Selection of projects. If you're doing a big, large enough project that's going to cut your consumption by 25-30%, we have seen projects where they installed a new dryer. The new dryer is so efficient that it's cut the consumption by 20-30% on the gas side. That might be the right time to get your gas company in, hey, listen, I'm going to drop 30% of my gas load. Can I go on a different rate that can be cheaper than that? Again, have those conversations. Here are some of the case studies. Before we do that, here's another video for you guys. This is more on the commercial building side of things. If you have a lot of rooftop units, things you can do to control your individual loads in the plant.
Having more control over electrical loads in your buildings means more savings, allowing you to reduce your peak demand, take advantage of demand response and other utility incentives, save energy, and reduce your carbon footprint. But this often requires installing and configuring expensive building management systems, plus constant monitoring of control units. It's like herding cats. Each unit operates independently, without cooperation, collective goals, or effective communication. What if there were a better way to manage your energy use with simple devices that automatically work together to maximize your building's energy efficiency? That's what Regen's Swarm Energy Management and its unique technology can do. At Regen, we're inspired by nature. Take bees, for example. Individually, a bee is pretty simple, but collectively, 1,000 bees working together perform large and complex tasks. They coordinate and organize without the need for centralized control. It's called swarm logic, and it's at the core of Regen's amazing patented technology. Like a swarm of bees, Regen's swarm controllers autonomously work together to maximize energy efficiency and minimize peak loads. Once installed on each of your discretionary electrical loads, a simple, inexpensive process that requires no integration with the building's network, our controllers, like bees, gather data and communicate via their own wireless network. They make decisions about when and how often units run, benefiting the system as a whole. Even with programmable thermostats, units can run simultaneously, causing coincident peaks in demand which increase your electric bill. Our swarm controllers work together to offset when certain units run, reducing peak loads and overall energy usage, all without ever sacrificing occupant comfort. Building managers can access real-time, sub-metered information across multiple buildings via our convenient web portal. You can group loads by zone, schedule recurring or one-time demand response events, and view real-time or archived data, all with little or no technical training. Taking its cue from nature, Regen's Swarm Energy Management is a low-cost, remarkable automated system. It delivers brilliant energy savings unique to the industry at a fraction of the cost of complicated building automation systems. Energy management made simple. Regen Energy. Take your world by swarm.
A movie theater chain installed this Regen, and since 2011, they've seen about $70,000 in savings. Another big box retailer also installed this in 2011 and have seen about $60,000 in the savings. Here's an example for power equipment. Rochester Metal Products installed this and have seen 25% reduction in the peak demand. Payback less than 3 months on the equipment. Here's an example that we mentioned about the arena. This arena used to have 1,000-watt metal halides that they have to change every 2 or 3 years. Now this is the LED side of things, and that's the fixture they installed. We have also seen this fixture. One of the companies that we are working with that manufactures airplanes is looking into this. Grocery store have just bought 1,000 of these to install. This arena installed it. There was enough light from the arena itself that they were able to shut off lights above the bleachers. So this is what was going on. There were 48,000 watt metal halides in there. They went with 48 500 watts of these. Over the bleachers, they have metal halide 400. And the numbers that you see in the bracket, it says 1,000 watt metal halide, but it actually uses 1,080 or at times 1,100 depending on the brand. Saved energy for lights as well as for the refrigeration. $8,000 to $9,000 per year saved in the cost. Huge maintenance cost savings because now they don't have to bring in the lifts, build the scaffoldings, and to get to the fixtures. Here's another example. A hospital that we are working with bought 300 of these. Stairwells, every building has stairwells if it's more than one floor. Lights are lit all the time because the code is you have to have light in them. The code doesn't tell you how much light they want in them when it's unoccupied. So you install a 30 watt fixture, as soon as somebody walks in, lights are at 30 watts, but when nobody's in there, it's down to 6 watts. But we are still meeting the code. Light has to be on all the time in the stairwells, right? A lot of hotels, schools, colleges, universities, everyone, a lot of commercial buildings have these stairwells. This hospital will save about $10,000 per year. And when I'm telling this to you guys, that savings per year, this is based on today's rate. Rates are not going down. And these fixtures, all these LED fixtures are supposed to last 10, 20 years. But guess what? They will start seeing the savings more. Here's another example. We'll play the video, but before we do this, that's the fixture this video will talk about. It's built by Philips, really good price. If you have a building and you have to bring in, you have to change the existing fixtures. The problem is you have to recycle everything and get rid of all those old fixtures. There is added cost. DLC is an organization run by Department of Energy. There are ton of LED products out in the market. Be careful. We have seen examples. Big casinos did major LED lighting company before, warned them, don't do it. They still went and did it. When it came time for the warranty, the company is not in business. Talk to Werner's. If you're buying through Werner or buying somebody a resource that you can rely on, you know that they're not going to sell you a product that won't be there or won't be backing up with a warranty. So DLC, DOE built this. Look for DLC approved fixtures. This is a DLC approved kit. It's the retrofit kit. Is one of, I would say, 5 or 6 that are out in the market that are DLC approved. You are listed kits that you can do in-house to make your lighting better. And it's sold as a lamp, so it's not sold as a fixture. Here's an example. We did a project. The picture is here too, with Werner up in northern Minnesota, and there was an old parking ramp that had high pressure sodiums, and this ramp product, they were able to see savings of $27,000 dollars a year in the ramp. The amazing thing about LEDs, they're instant on. So you can install controls on them. If there is enough natural light, hey, shut those LEDs off, because now you don't have to worry about something that will take forever to come on. Some refrigeration projects that we have done, refrigeration control system. Again, these were more on the food processor, large food processors. Saw savings of $48,000, $38,000 rebate, ROI of 4.5 years. Heat exchanger, recover waste heat wherever you can. Take advantage of the heat, because in Minnesota we need heat in winters. $16,000 savings, $10,000 rebate, less than 7-year payback. Waterlogged roofs. It was causing insulation problems over the refrigerated warehouses. $9,500 savings, $9,000 rebate, 12-year payback. 12-year on installation project, roof project is really good. Usually they last about 26, 27-year paybacks. And hydrator, when water get in your refrigeration lines, cost savings of $7,500, rebate of $5,000, ROI of 3.5 years. High-speed doors, a lot of, you have to take all the moisture out of this, but if there are doors that are not controlled and that are not closing properly as the equipment is exiting through your refrigerated cases or warehouses, or it just causes more problem. More compressor has to run more to take that humidity out. So installing high-speed doors, $7,500 savings on each case, on each room. Rebate of $7,000, ROI less than 2 years. Grocery store, change the battery chargers. Nowadays, almost everybody have battery chargers. Going to high efficiency battery chargers, savings of less than 7 years. Again, you folks are doing these projects. Ask the reps for the rebates. Ask them to see how much they can help. UPS, a data center, high efficiency UPS is seeing less than 3-year payback. Food processor, compressed air. Almost everybody has compressed air these days. Compressed air, there was, they increased the header pipe size and installed variable frequency drive control compressors in a food processor again. $38,000 savings a year. Less than 4 years payback. Compressed air is only 17% efficient in a very good system. That's why compressors are so good to make heat in the plant, because all that waste energy, all the electric energy you're putting in, only 17% good work is coming out of it. So whatever you can do to make those efficient, great idea. And a lot of utilities, I know Excel does, offer compressed air studies, but a lot of people don't know this fact that it's only 17% efficient. A good system is 17% efficient. Chiller with economization. The great summers we are having this year, perfect candidate for economization. Use that free cooling. Grocery store dehumidification. We work with a grocery store chain. Rather than a lot of people, this is how it's done. To dehumidify, you cool the air, molecules come close, and it drops the moisture out, right? There are technologies out there that you don't have to spend money on refrigeration, on cooling, but go with a more efficient system. So looking into a real dehumidification system can help you save energy too. So here's an example, less than 4.5 years payback. Dust collectors, again, great candidates for variable frequency drives. Dust collectors are notorious to run those motors all the time. Plus, they take your conditioned air out of your space, and out it goes, because then your air handling unit, makeup air unit is trying to make that up. And in winters, if people are complaining it's really, really cold, first thing we do is look for the dust collector. Install variable frequency drives. If you can slow down the motor, you will save energy. Another example for you guys to get an idea how these variable frequency drives work. If I have to go from point A to point B, a normal person would use accelerator, right? A bad driver like me at times would just use this, pump it down the speed to 100 miles an hour, but then use brakes. And then my boss says, I hate your driving. But you just press the accelerator and you're using brakes. When we all know to use an accelerator, why don't we do the same in our industries? When we are putting a damper or a valve on a fan or a motor, we are running that car at 100 miles an hour but using our brakes to slow it down. Install a variable frequency drive, slow down the RPMs of the motor. And variable frequency drives are smart. You can send a signal back to them. Install suction pressure controls in dust collector piping, send a signal back to the drive. Hey, I'm feeling a lot of pressure, there is a lot of dust in the air. Ramp up the motor. It doesn't have to run all the time. Things like those can be done with Werner's help, automation people help that can come in and design the system for you. Paybacks, this was a 500 horsepower motor. That's why the payback is up there. But a variable frequency drive, these days you are looking at paybacks with your energy rates between 2.5 and 3 years. Why not do it? And every RPM you save, you slow down your motor, you cube the energy. A lot of times, all the motors are over-designed. When they were over-designed, energy wasn't an issue. Now, in your profits, energy rates play a major role. When you know that your motors were over-designed, what can you do to at least save some money on the over-design side of things? Variable frequency drive. So here are variable frequency drives can also be used for demand control. This is how. You have to fill up a bucket of water, okay? Either you can fill up that bucket of water by opening the tap full, let it full, right? When you open the tap full, you are paying that peak energy rate. Or you can install a VFD on it. Never let the tap go over 50%. Guess what? You will never hit demand higher than 50%. It will take a little bit longer to fill the bucket, but again, that's another way of peak demand, peak control. Okay. Some other examples that we have seen in the plants, process equipment, like you brought up an example earlier. What can you do? Yes, you will be using more energy to produce more plants, more parts. Are you using less energy per part? If you are doing that, if you're making these changes, connect with your utility, you can get rebates for those. Hospitality room controls, another great example. Data center upgrades. Transformers, a lot of folks have these in the plants. You know there are rebates for those. If you buy an efficient transformer, that means you have less losses. Let the utility know. Consider that for your calculations. These are taken for granted. I have seen that, I have experienced them a lot. Just install a transformer. No, if you are going the energy efficiency route, reduce those losses. Compressed air, like compressed air, vacuum acts the same way too. Refrigeration, heat recovery, boilers, hot water heaters. And again, your Werner reps are around you. One of them is sitting down, rest of them are standing in the back, asking the question.
3 are sitting down.
Again, a little bit for our company, we are passionate what we do, we are committed to our customers, and we promise you if you use our help, we'll be out there to help you out. Any questions for us? Yes, sir.
So you take a 500 horsepower and put a VFD on that. What else are you introducing into that power quality? You got harmonics and power factor. What does that VFD cause? Power factor, harmonics.
It actually reduces the power factor in harmonics. Because what's happening, if there are two ways of using a VFD. You can use your VFD as a soft start. Don't do that. It will be too expensive of a soft start. When you install a VFD, have something that sends a signal back to it that reduce the motor RPMs based on the CFM needed, or reduce the pump RPMs based on the gallons needed. If you are changing that frequency, reducing that down, then you are just using the motor for the amount of work you need out of it. But if it's running harder than what you need it for, that's what creates power factor and harmonic. Is that what you were asking?
Yeah, and there's an issue we're running in our plant that we had 300 kVAR factor bank on I think it's a 2,000 kVA 480 transformer.
Okay.
Blew up twice. So we're trying to figure out what the resonant frequency has anything to do with harmonics. If it's 357, it's blowing up these cap banks.
You know, I'm not sure how to answer that question, but if somebody from Werner or Matt, can you help out?
Okay, there's some power monitoring equipment you can probably install, find out, and dig into the get it done already.
Yeah, we have some on it now, and that's how I monitor the 5th and the 7th, so we could talk about it later after.
You bet.
So, all right.
Any other questions? Please.
So I've spent a lot of money on an arc flash study, and then I go and I install a VFD on a large motor. How is that going to, is there an impact on my arc flash study that needs to be considered?
I didn't think so. Yeah.
Change breaker, change some of your MCCs, or you know, data.
Just install the VFD.
That all stay the same.
It's almost more so, it might, I believe it might make my hazard category lower because I've removed that motor load as a generator. If I've got the proper type of VFD, it's now eliminated that particular motor from the effects of feeding back into an arc.
Yeah, but as far as the arc flash, it's really considering the source as really the short circuit current available to that circuit. The drive itself is a current limiting device. It's just really an elegant fuse in that circuit. But it's really the available power that is feeding that particular cabinet. That's really the energy study.
So essentially, would lower my hazard category, coming back to the upstream current, upstream protective device. So, all right.
Any other questions?
I think you're good then. I have questions. Yes. Everybody has this flyer in front of them. This is for another invite that only costs you your time for June 10th and 11th. It's a technical 2-day seminar that is identical both the 10th and 11th. You're invited to come for an hour. You're invited to come for both days, depending on what it is that you want to find out more detail about. So a couple of the things that you saw a video on, like the powered solutions, the demand management piece, that's one of the classes. There's classes on energy management software, power monitoring devices, all sorts of widgets that can help you, that you can use to implement to improve your energy usage. That really kind of, that's a whole lot of information to use. Thank you very much for that excellent presentation. I wanted to boil that down to really the high points. And what you pay for as a consumer of energy is really 3 things that you have some control over. The rest of the things are because of those 3, right? So it's really what you consume, which is energy, so that's power over time, so it's kilowatt hours, okay? So the more you consume, the more you're going to pay for, but you have a certain baseline that you absolutely need for your facility to produce what it produces, okay? The next piece is power, kilowatts. So if you're asking for peaks from the utility, they're going to charge you for those peaks, and it may be because you only used it once, right? And when you mentioned the 15-minute interval, right? So a demand management type situation looks at what you're doing over a 15-minute moving average, right? So if you start a large compressor on minute 1, don't start the next one until minute 16 or 17, right? Because that gets averaged in there. So someone that would drive a car properly would accelerate up to a certain speed and put the cruise control on, and there's no surprise to the utility. That's what they want. They want consistency. They do not like surprises. Okay, when it comes to how much do they have to have in their infrastructure to supply to you, right? So if everybody did that, they'd have a nice, perfect system. So that demand management tries to even out those loads for you. Okay, the third thing is power factor, which is how well you use it. Okay, so the more inductive load you have, the worse your power factor, because there's a lag between voltage and current. You're paying for volt amps. Most of the time you hear kVA, and then you hear kVAR to correct for that bad use of kVA, right? So there's that phase shift. So what you want to do is play Eli the Iceman, for those of you that understand that, right? Inductive circuit, voltage leads current. Passive circuit, it's the other way around. So you add a cap, so you bring them more into alignment, okay? So if all you had was a resistor load, you'd have perfect power factor, 1.0, right? They're both in alignment. So the more you can get those aligned, the better you're using that, the less heat in your transformers, the less heat or infrastructure that the utility has to supply for you to get that motor shaft to turn, okay? Volts and amps that are in phase create shaft work and rotation. That which isn't is magnetizing current or heat, right? Like you said, compressors are a great place to hang out in the winter, right? That's where you see the guys on break. Ooh, it's nice and warm in there, right? But all of that heat is not useful, right? Old lighting, great heat generators, lousy efficiency, okay? So now we're aware of those three things. If you do those better, all the sales tax and the fees that are tacked onto poor use of that kind of get limited too. So by taking control of that, you have a better opportunity to have sustainability and profitability, okay? So that's wonderful. How do I know what I'm doing? Well, you have to measure it, right? And you can measure it one time to get that baseline and figure out which piece of the pie you want to attack first, all right? So getting measurement equipment, whether it's one time to do a simple study or to have permanently, depending on what you want to achieve, right? Measure it, analyze it. If you want to do demand control, it's not a one-time thing. You have to be monitoring real time so that a control system can take over and make sure that you don't start all these loads or cycle these loads. It may have an impact on your production at first until you figure out maybe you have to do a little shift in time on when you do things. I mean, you can do some pretty radical things like I should have preloaded this room to 5 degrees lower before everybody got in here. So by the time we all got in here, it didn't spike up. And then we had to crank the air conditioning because it was about 10 degrees warmer here after everybody showed up, right? So you could preload that on off-peak hours, and then when it's peak, you've already pre-cooled the area. Those are the types of things you can get. So if you want an energy management system, it really means permanent installation of equipment. And it can be very scalable. It can be from a current sensor to a full-blown harmonic analyzer system, depending on what you're looking for. Power quality, right? Talk a little bit about power factor. Technologies will create byproducts that you may not necessarily want, but you get. Whenever you do power conversion, you get what you want, and sometimes you get something else, all right? This is typically a high frequency type thing, like harmonic, or really high frequency that may affect some sensitive devices. So harmonics really are multiples of a base frequency. So if it's a 60 cycle system, a harmonic is a multiple of that, right? So you had mentioned like fifth or seventh. If you have 6 devices converting power, you always get the harmonic that's one less and one more than that. So you have a lot of fifth and seventh if you have very low frequency drives because there's 6 pulse devices, okay? So the question is, what's too much? Every motor that runs across the line sees that harmonic. That harmonic adds heat. Every other device that's in there sees those types of things. So it's just the awareness of what's too much, right? And then high frequency noises, you'll know when it's too much because something doesn't work. The question is, what ghost are you chasing? Do you know what you're looking for, right? Now's the time of year where people like Randy get called often because he's the drive guy. The drive failed because the lightning storm came through. Well, the lightning storm wasn't planned on up front because a lightning arrestor wasn't put in, transient voltage surge suppression wasn't put in, or some other equipment down the line may have failed because of that. So what's worse than downtime or a failed unit? Being out of business, right? Because you're out of business there temporarily. So that's why I don't think you can separate power quality from energy management because it's all about producing widgets for the least amount of cost, all right? Most every installation or upgrade that you're going to do to a process is going to improve the efficiency and is going to lower your cost per widget. So don't only look at things as a energy reduction program. A lot of times it's a process efficiency, the byproduct is that improved efficiency. Okay, so you got to look at it both ways. A lot of rambling, sorry. That's all I got off the top of my head. I invite you to give us questions here or pull us aside and talk to us. Just a quick raise of hands. Who's seen a utility bill for their facility? Who was kind of amazed at how much you use? Right? I know. I look at it the way I look at my utility bill or my personal finances at home. Every time we get the utility bill, my wife and I look at it and go, yeah, we're doing okay. Or, wow, that was really cold in February, right? Because I saw an amazing spike in my heating bill. So, again, June 10th and 11th, if you're not the person that wants to learn the techie things, please send someone that does want that they really give you some good input on those particular products. And the last thing, the end of the month, we're actually installing a bunch of stuff here in our distribution center. So we're going to have a plethora of different products that are scalable from current sensors on our exhaust fans to a full-blown harmonic analyzer on our utility feed, and then the software to integrate that. So I'm going to know how lousy we are with our 15 rooftop units. I'm going to know how much we spend on the lighting. I'm going to understand when the conveyor's running, when the compressor's running, how much that solar panel is giving us, how much wind energy we're actually getting. And then we're going to get things from the conveyor system that are in a energy object format, which because we have a lot of Rockwell product on there. So essentially what it's going to do is it's going to give us in a native tongue the information that we need without any special program. All right? So there are objects that have built-in power monitoring within them, so I don't need an extra piece of equipment to tell me that data. So that's going to be some pretty cool stuff. Questions or comments for me?
For the event coming up in June, if you do want to attend before you leave, you can just sign up right back here before you speak out.
Nice. Thank you all for your time. Appreciate it. Thank you.